So today we're looking at chapter 4-3, angle relationships and triangles. There's really two main objectives in this section. First is I can find the measure of interior and exterior angles of triangles. And we're going to look at the definition of interior and exterior in just a little bit. Second objective is I can apply theorems about interior and exterior angles in triangles. But first, I have a little activity for you to do. So I'd like you to just follow along with the video. Okay, so you're going to need a few things for this activity. You need your notebook, a piece of paper, 3 colored pens, and then a black pen. And a pair of scissors, and a ruler or straight edge, and then some tape. So what you're first going to do is draw a triangle on the bottom of your white piece of paper. It can really be any kind of triangle. It does not have to be like the one I'm drawing here. Okay, so now you're going to grab one of your colored pens, and lower right hand corner, shade in the color, and then label that angle 1. Then pick another color, do the other one, and call that angle 2. And then finally the third color, you'll fill that in and call that angle 3. Alright, so now I'm just going to take your scissors and cut out your triangle. Now, also you can pause this video as we go through so you can catch up. That's perfectly fine. So now in your notebook, you're going to take your black pen and mark the 3 vertices of your triangle. Then take your triangle off and then use your straight edge to connect them to make a copy of your triangle on your notebook. Okay, so now you're going to take your colored pens and copy it down just like it is on your piece of your triangle that you cut out. Okay, so now you're going to take your triangle and you are going to tear off one of the angles like that. Then you're going to split the other 2 angles. So you can tear it into 3 pieces. Each piece has one of the angles. Then you're going to take number 1, lower right hand corner, take some tape, and you're going to tape it down just like this. Then you're going to take angle 2. You're going to line up right to the right edge of it, just like that, and you're going to tape that down. Then finally, the third one, you're going to line up to the right side, and then tape that. Now what we want to do is think about what is the sum of all the angles in that triangle. By doing this activity, we did an informal proof to show that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 will equal 180 degrees. So the sum of the interior angles of any triangle will always equal 180 degrees. So here is the triangle sum theorem. So as promised, we're going to look closer at interior and exterior angles. So we're going to look at this triangle here and then draw an extension from one of its sides out. And then inside the triangle is the interior of the triangle is the interior angles. So for example, angle 1, angle 2, and angle 3 here are all interior angles. So on the outside is the exterior angles. So angle 4 would be an exterior angle. So let's go ahead and write out those definitions. The interior angles is formed by two sides of a triangle. So it'll be angles 1, 2, and 3. Then the exterior angles, so they are formed by one side of the triangle, like this one here, and an extension of an adjacent side, going out this way here. So it'll be this side and the extension of this adjacent side. Now I'm going to have you do a little activity where you look at the relationship between the interior and exterior angles of a triangle. So for this activity, you need the same supplies you used earlier in the lesson. So you're going to take your plain piece of paper and your straight edge or ruler. You're going to create a new triangle. And this triangle is going to be different than the last one. I'm going to try to make mine look a little bit different. Okay, and also just like the last one, you're going to color in each corner and then label it. So I'm doing lower right is angle 1, lower left is angle 2, and the top angle is angle 3. I'm going to cut out my triangle. Okay, so I'm going to orient my triangle, so angle 1 is in the lower right hand corner. And just like last time, I'm going to mark the 3 vertices with my pen, and then use my straight edge to make the triangle. I want the triangle to look just like the last one, or just like the one I made that I cut out. So I'm going to fill in each of the angles with the color to match the cutout triangle. Okay, and I'm also going to do an extension of that adjacent side there. Okay, and just like the last one, I want to take my triangle and tear it into 3 pieces. Have 1 vertice on each piece. And this time what I'm going to do is tape my angle 1 over the angle 1 I have on my paper, just like that. Then I'm going to take angle 2 and line that up right next to it, right there. And then angle 3, I'm going to put next to that one. And based on our definition above, I'm going to label that angle the exterior angle. And then I'm going to label angles 2 and 3. I'm going to call them the remote interior angles. So they're interior angles, and we call them remote interior angles because they are the interior angles opposite the exterior angle. Now I want you to make a conjecture about the relationship between the exterior angle and then each of the interior angles. Okay, so what we have discovered is another theorem. And that theorem is the exterior angle theorem. So what the exterior angle theorem does, it says that the measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3 when using the diagram up above or in the notebook. Another way to say it is the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. In addition to these important theorems, there are two corollaries that I want to share with you. So here are the two corollaries. The first one is that acute angles of a right triangle are complementary. And complementary, as you may recall, just means that they add up to 90 degrees. Because of this triangle sum theorem, we know that all the angles need to add up to 180 degrees. And since one of the angles is 90 degrees, we know that the other two have to add up to 90. Another way of looking at it is using the exterior angle theorem. And so the exterior angle off of vertex F is 90 degrees. So therefore, D and E, those angles there would be the remote interior angles. So they would also need to add up to 90 degrees. The next corollary that we're looking at is the measure of each angle of an equiangular triangle is 60 degrees. And equiangular also means equilateral, so we'll assume this works for equilateral triangles too. And because of the triangle sum theorem, we know that all the angles need to add up to 180 degrees. And since it's equiangular, we know that all the angles are congruent to each other. So what we can do is divide 180 by 3, and that gives us our 60 degrees for each angle. So now we're going to look at one example of applying the theorems that we've learned. So in this one here, we're asked to find the measure of ACD. And we're going to need to use the external angle theorem to help us do that. So we can write this as the measure of angle ACD is equal to the measure of ABC plus the measure of angle BAC. And then using substitution, I'm going to put in the expressions or the value for each of those angles. Right, then we solve for z. So I'm going to start off solving for z by subtracting 2z from both sides. And then when I do that, I'm going to get 4z minus 9 on the left-hand side. On the right-hand side, I'm going to combine the 90 and the 1 to make 91. So I'm going to add 9 to both sides. So we get 4z equals 100. Then divide both sides by 4. So then you get z is equal to 25. But we're not asked to find the measure of, or find the value of z, we're asked to find the measure of that angle. So here I'm substituting 25 back into that expression of 6z minus 9. So I get 150 minus 9, and that will simplify down to 141 degrees.